Hi, I'm Andy Hind. I'm the System Architect for Search Analytics here at Alfresco. I'm part of the overall architecture team. It's our job to come up with a digital business platform that's scalable, resilient, and flexible. Today, I'd like to talk about the components that make up Search Analytics. I like to think of search and discovery in three parts. There's the index, which reflects the information in the repository. There's how we build those indexes and how we use them at query time. First of all, what is an index? Well, it's a collection of document states that are held together and that you can query together. The state includes the metadata for the documents, the content, the access rights, and where it lives in the repository. There are several different types of states. We typically index three kinds of things. We index the live documents in Alfresco, we index things that have been archived, ready for deletion, and we index all of the versions that are in Alfresco as well. Those indexes can get quite large, particularly if you keep lots of versions of documents, for example. At some point, you need to split them up for scalability, resilience, and redundancy reasons. When we do that, we call it sharding. We create and split the index up into parts. There are several ways you can do that. You can do it based on random assignment. You can do it based on access rights, using a date, like the created date or the destruction date. You can also use the sequence of when it was created, and there's a whole bunch of other things. Customers have different use cases, and the sharding case, which sharding method you want to use depends on what you want to do. Sequential assignment of shards as you create them means that you can create an auto-scaling model. You can fill up one shard when it's full, for whatever reasons you want. Maybe you hit a query restriction or a query speed thing, you can go to the next shard, and you can just keep adding shards in a scalable way. If you have a more customer-focused case where you always query with a customer ID, you can then split your data based on customer ID. And all the information about a single customer goes in a single shard, and that means you can use that shard on its own at query time. The Search API has two parts. There's the REST API, which ties in with the public API exposed in the repository, and there's a SQL API exposed over JDBC. Using the REST API, you can query the content of the repository in two query languages. You can use the Alfresco full-text search query language, and you can use the CMIS query language that's defined in the CMIS specification. Any results that come back from the API reflect the user's access rights. You can only see the things that you're supposed to. If you do aggregations and counts and sums, then those also include only things you're allowed to see. If you're using information governance services, then you may have applied security markings to your documents. Again, those are reflected in the results that come back, and you can't see anything that you shouldn't be able to see. When you execute the query using the API, you can look at any of the indexes that we've talked about already, the live index, the archives, and the versions, or you can combine them together. JDBC is there to expose SQL to business users and to integrate with business intelligence tools. At the moment, we're using Apache Zeppelin to build reports using little SQL snippets that add little bits of reports from content that's held in the repository. Next, I'd like to talk about three more pieces. How the data model affects indexing and querying, how we build an index, and what happens at query time. First, the data model. The data model is a key part of the repository, and it also has an important function for search and discovery. So the data model defines types and properties and some other things. We're mostly interested in properties. The type of a property defines most of its behavior when it comes to query and index time. For text properties, there are some more options. You can treat text as an identifier. You can look for the words within text and do full text search. You may want to use a property for ordering or for aggregation. You may want to use a text property in a localized way so that it makes sense if you're searching in English or French, or you may have something in there, again, probably like a customer identifier, where the language doesn't matter. You need to consider all those options when you're creating a property and think about how you're going to use it when you come to find things based on that property, or how you're going to use it in aggregations. Of those options, you can combine any of them together. You're allowed to have an identifier that you also use for full text search, that you use for ordering and faceting. Next, how we build an index. When we make changes in the repository, we track when those changes take place. The database has a log of when things happened. The index can use that log to build a copy of the database. And it keeps track of what information it has added already. Now, there's several bits of that information. There's the model and how properties are defined. And we've already talked about how that affects how things are indexed and queried. There's the metadata for each bit of content. That gets added to the index and pulled in its own right. Once the metadata has been added, we can go and add the content to those documents. And we also pull information around access rights. We make sure that information goes live in the repository in the way that it went live in the database, so that at any time the version of the index reflects a state that used to exist in the database. Eventually it will catch up, but it will always reflect something that was there in the past. Each index that we build is independent. It's built in its own right. It knows what information to fetch and where to fetch it from. It doesn't rely on anything else. We can also do things like build more copies of bits of that index that receive more queries, and that means we can make that thing scale out in a way that reflects how it's used. Finally, how queries are executed. We have two ways of executing queries. We can go to Alfresco search services, which we've been mostly talking about today, or we can go to the database. So when you use Alfresco search services, there's always a little bit of lag. We have trackers that have to go and pull information from the repository. That never happens quite immediately for some people, and in those use cases, they can execute queries direct to the database. Not every query can go direct to the database, only the simple ones. So when you execute a query via the REST API, we look at the query, we do some analysis, and we decide where to send that query. If it's simple and somebody's asked for it to go to the database, we can do that. For other cases, we send everything over to search services and execute the query there. The query that you run over here is in a query language. It encapsulates properties in the data model in a particular way. That will never change. So even if we change the implementation of search services, or we change the persistent engine to use something other than a database, that API will remain the same and your queries will remain the same. When we execute things via the JDBC driver, that goes direct to search services. There's no option to go to the database, largely because this involves lots of aggregation and counting and summation, and it's key to enforce permission rights as part of the query. The database is restricted to some of the smaller queries as well. If you're expecting millions of things back, then going to the database is not the way forward, and applying those permissions and having that stuff happen in query is the key thing to do. Underneath the covers, we use Apache Solr, which is a very popular search engine built on Lucene. We are involved in the community, and we're also involved in making contributions to the project. So we've added things related to the JDBC driver and the way that's implemented. Members of the team have also been involved in submitting contributions for patches, for bug fixes, for things related to SSL and security, and also for looking for documents based on fingerprints of what the content contains in those documents. I hope you found that information informative. There's more details on our web pages and in blogs, in particular how we use that architecture to scale to 1 billion documents and beyond. Thank you for your time.